Okay, so I'll just post a link after class for this. We are finishing chapter 9. Monday we cover section 10.1, which is a lot of graphing. Tuesday's review, Thursday's a test. If you're behind, you need to get caught back up. Okay, so this section we're using a table. You guys all have the table, I gave it to you. And what we're doing is we're going to be plugging functions into these series on the table. So there isn't really a lot of work to what we're doing, except on occasion where we have to take the derivative or the integral of a series. But mostly it's just plug into this table. I like to call this a function composition method. So, use function composition to find the Maclaurin series for f of x equals sine of x squared, and then find the interval of convergence. So that's good. The series for sine x, if you look on this table, they didn't write it in series notation, but they give you the nth term on it. So go down until we find sine x, and the nth term, that's the formula that we're going to put inside our series. That's going to be the sum minus 1 to the n, x to the 2n plus 1 over 2n plus 1 factorial. And now if you look at it, notice the sine x is starting at x. We have to guess where the endpoint starts here for the series. Does it start at 0 or does it start at 1? If you plug in n equals to 0, do you get an exponent of 1 leaving you that x term at the beginning of your series? Yeah. If you do x to the 2 times 0 plus 1, that gives you x. That's the first term. So we're going to start at n equals 0 and go n equals 0 to infinity. And that's going to be our series. On the far right-hand side of the table, it tells you the interval of convergence. What is the interval of convergence for this series? Negative infinity to infinity. Now, we are asked to find sine of x squared. So I'm just going to plug in x squared for x. And we have x squared to the 2n plus 1 over 2n plus 1 factorial. Simplify that exponent. And you're going to have x to the 4n plus 2 over 2n plus 1 factorial. And then we have to determine the interval of convergence. For x squared, the domain is going to be minus infinity to infinity. Remember, x squareds are a parabola. It can take any x values. You're not taking the square root of a negative value. You're not doing a fraction there. So any real number works here. My domain for my sine x was minus infinity to infinity. So because they're the same, I choose minus infinity to infinity for the interval of convergence for this. That's how difficult these problems are. You just have to figure out what to plug in, how to simplify it. Sometimes we have to take an integral, sometimes we have to take a derivative, but they're really not that bad. Any questions on this? Kind of nice after everything we did yesterday, right? Yeah, those derivatives bother you? Find the power series for the function f of x equals to cosine square root of x. So let's look up cosine x. On our table, that's going to be minus 1 to the n, x to what power? 2n. Oh, that's horrible, 2. Over 2n factorial. N equals what? Where do you think it's going to start? Is 0. N equals 0 to infinity. There's the series. So now on what is its interval of convergence? Negative infinity to infinity. Now, what is cosine of the square root of x? Remember, square root of x is x to the 1/2. So what's that? Square root of x is x to the 1/2. So plug that in. Simplify your exponent. What is 1/2 times 2n? X to the n. And now we have to think about the domain of the square root of x. Where is that defined? Can you plug in negative numbers into that function? No. Can you plug in 0? Yes. Square root of 0 is 0. So that interval is 0 to infinity. The first one was minus infinity to infinity, and we go from 0 to infinity. If you think about it, this is 0. This is our minus infinity. This is our infinity. It goes from here to here. And we want from here to here for the second one. So they overlap from 0 to infinity. Does that make sense? You're choosing where they overlap. So what is our interval? 0 to infinity. Any questions on that? Bless you. Not too bad so far, right?
So your interval convergence would be
0 to infinity, including 0. Yeah. You restrict it to where both of them, the domain and your series, converge. So let's do another one. Find the power series for f of x equals sine squared of x. Find an interval of convergence for this power series. This is sine squared of x. However, if we look at our tables, we definitely don't have a sine squared on our table. Remember, sine squared is sine x quantity squared. And we really don't want to multiply our two series together. Multiplying series is really painful because you have to do FOIL with an infinite number of terms. This is very problematic. We stay away from that at all costs. So what we're going to do is use our trig identity. What is sine squared of x according to the trig identity? 1 minus cosine 2x over 2. So I can write that then as 1/2 minus 1/2 cosine 2x. So let's write down our cosine x series. That was a sum n equals 0 to infinity, minus 1 to the n, x to the 2n over 2n factorial. And then the interval of convergence is minus infinity to infinity for that. We have to find cosine 2x. So plug in 2x where you have x. And now we're going to multiply it by the 1/2 out in front. And I'm actually going to multiply it by the minus 1/2 and add the 1/2 at the beginning. So that's going to be equal to 1/2 minus 1/2 times the sum n equals 0 to infinity, minus 1 to the n, 2x to the 2n over 2n factorial. I'm good with that for an answer. WebAssign may want you to take this 1/2 inside, but there's no particular reason to do that. It doesn't cancel with anything really well.
So the way that we were 4x or 2 times.
Okay, so what would it do if you took it inside? That's what you're asking.
Yeah.
So this 1/2 goes in the denominator. I'm going to bring this 2 out. That becomes 2 to the 2n, x to the 2n. You can't combine it with your 2n factorial over here because that is a factorial. That's 2n times 2n minus 1 and so forth. But you can cancel it with one of the 2's in your numerator, leaving you a 2n minus 1 in your exponent. So you get 1/2 minus the sum n equals 0 to infinity, minus 1 to the n, 2 to the 2n minus 1, x to the 2n over 2n factorial. And if you want to go one step further and see if this 1/2 can cancel with one of the first terms from this series, you can take that first term out and add it together with that if you want. And when you do that, I'm going to go down here, you'd have 1/2. If you plug in n equals to 0, you're going to have minus 1 to the 0, 2 to the 0 minus 1, x to the 0, over 2 to the 0 factorial. And then you'd start at 1 over here. What is 2 to the minus 1? 1/2, right? What is minus 1 to the 0? 1. X to the 0? 0 factorial? 1. So that just leaves you a 1/2. You have a 1/2 minus a 1/2. That's going to go to 0. So you're actually just left with minus a sum n equals 1 to infinity, minus 1 to the n, 2 to the 2n minus 1, x to the 2n, all over 2n factorial. You can go that far if you want. If WebAssign takes it sooner, you can stop sooner. I really don't care if you go that far. Questions? Yeah?
Why do you have to minus 1/2 cancel? So it doesn't block.
I'm good with you stopping it here.
Yes. But if you want to be inside WebAssign, you have to pull that forward.
No. I don't know how far WebAssign is going to require you to go, but I'm betting it'll take it right there. As long as it doesn't put the summation series out in front. If it puts the summation series out in front, then you have to combine them together. Yeah. Okay, so any other questions? Yeah.
How does 0 factorial equal 1?
That's just a definition of 0 factorial. It's defined using what they call a gamma function, which is a factorial for non-integer values, and taking the limit of the gamma function as your fraction goes to 0. But that's where it comes from. But we haven't taught you guys about those gamma functions yet, so don't worry about it. It purely comes from a limit, but it's defined to be that way. Okay, so what is our interval of convergence? We have to go back and look at our 2x that we plugged in here for the cosine. 2x. What is the domain for 2x? Just 2x. Minus infinity to infinity. The cosine x was minus infinity to infinity. Where is the overlap for minus infinity to infinity? All of it, minus infinity to infinity. So there's your answer. Right there. Any questions on that? Okay? Let's look at this one. Use our power series to approximate the integral of e to the minus x squared with an error of less than 0.01. Remember, way back when we first started talking about u substitution, I told you there were some integrals that you just couldn't evaluate, but we knew they had answers. This is one of those ones you just can't evaluate. E to the minus x squared, because if you make u be equal to minus x squared, you have a minus 2x in your du term. There's no x term down in front of that e. We can't integrate that any other way than a series expansion. But this is a very, very important integral. Those of you in statistics, we have a normal distribution in statistics. It's a bell-shaped curve. It is exactly from this e to the minus x squared. It's got some constants in front of it, but that's the graph of e to the minus x squared. It's your bell-shaped curve. This approximation is used over and over and over again. The most common approximation. The most common distribution in statistics is your normal distribution. We use this guy all the time. We have to be able to integrate it. So we integrate it using a power series approximation for it. We have a power series for e to the x. On our table, what is e to the x equal to? What is the nth term on the table? X to the n over n factorial. And let's figure out where n starts. Notice the series starts at 1, so I need x to the n over n factorial equal to 1. And that happens when n is equal to 0. X to the 0 is 1, 0 factorial is 1. So this starts at n equals 0 to infinity, x to the n over n factorial. I need a minus x squared. So e to the minus x squared is going to be the sum n equals 0 to infinity minus x squared to the n over n factorial, which I can simplify by writing minus 1 to the n x to the 2n over n factorial. Taking that minus 1 out in front. Now let's integrate. That's going to be the integral from 0 to 1 of the series n equals 0 to infinity minus 1 to the n x to the 2n over n factorial. And we're going to integrate with respect to x. Remember, we can interchange the integral and the summation because this is an absolutely convergent series. Power series is absolutely convergent. So I can interchange the integral and the power series. What should we do with our minus 1 to the n and that n factorial? They're constants. Pull them out in front of the integral. So I'm going to have minus 1 to the n over n factorial. And then what's the integral of x to the 2n? Add 1 to the exponent, x to the 2n plus 1. Divide by your new exponent. And then remember, we're plugging in 0 and 1 for the x values. I'm going to write this as n factorial times 2n plus 1. And now let's plug in 1. We're going to have 1 to the 2n plus 1. And then we'll plug in 0. What is 1 to the 2n plus 1? 1. And 0 to the 2n plus 1? 0. Now we're going to assume that the infinite sum of 0 is 0. So that leaves us on our series the summation n equals 0 to infinity minus 1 to the n factorial 2n plus 1. And now it says approximate this with an error of less than 0.01. So let's go look at the kind of series we have. What type of series is this guy right here? Alternating series. The remainder formula for our alternating series is simply the next term. So Rn is going to be less than or equal to, and we just plug in our next term on it. In absolute value, that's going to drop that minus 1 to the n, and I'm going to write it as n plus 1 factorial, 2 times n plus 1, and we want that less than or equal to 0.01. And then how did we solve these? Calculator. Guys got a calculator? I know you guys have calculators. Engineers and computer science and math, someone has a calculator in here. Put it in the table in your calculator. And tell me what value of capital N gives you the first term smaller than 1 over 100. I actually did this last night. I got n equals to 4. Now what you guys got? You can put it in a spreadsheet in Excel. I got n equals to 4. What does that mean? I have to add up the first 4 terms. So my integral is going to be, add this sum, n equals 0. I'm going to have minus 1 to the 0 over 0 factorial times 1 plus minus 1 to the first power over 1 factorial. 2 times 1 plus 1, it gives me 3. Plus minus 1 squared over 2 factorial times 5. Plus minus 1 cubed over 3 factorial times 7. Plus a minus 1 to the 4th over 4 factorial times 9. When you add those together on your calculator, you should get, oh, I didn't add them together, I just wrote them down. 3 gives you 0.02381. That's bigger than 0.01. That's what you get with 2. Did you plug in n plus 1 when you did it, or n when you did it? Huh. Did I do that wrong? Let's see. If I simplify this, I'm going to have 1 over n plus 1 factorial, 2n plus 3. Guess I'll pop up my computer and see. So we have, I don't know why it's doing that. I think a tiny screen over there. Y equals to 1 divided by x plus 1 factorial times 2x plus 3 I don't know what it's doing. It's really messed this up. Let's clear that. There we go. And then let's go to our table. Yeah, I was off by 1. I was doing it by hand. N equals to 3. Yep. N equals 3. I have to change that in my book. I did that last night. So that means I only have to go up to the first three terms. I did not add these together, though. You would think I would have. Question? You have a question?
What part of this whole assessment, you know, you said earlier that you're asking questions or Excel?
I'll give you one of these that you can actually do by hand on a regular calculator. Yeah, it'll be something easy that you can plug in. Okay, so this sum right here, I'm not going to calculate it, but that's what you would approximate U series by. You guys can add that together. Question? Yes. Do who did what? Yeah. Yeah. Okay, you guys have a classwork problem to work on today? And you are going to want to make sure you write it clearly so that you can follow it later, because it's just like one of your homework problems from WebAssign. I took one of the homework problems off of WebAssign, so that should make your homework easier later.